Now it's fine. Now it's fine. Switch on the light.
Sir, light.
Now it's okay.
1 minute, sir. 1 minute, sir.
Okay. Now it's fine. So we'll start exactly at 2:30.
Fine, sir.
So we will wait for 5 minutes and then we'll start.
Can I share the
You can share your presentation.
Okay.
I'll just give an introduction for you. Then you can start.
Yes, sir.
Fine. So, a very good afternoon to all. Welcome to 5 days faculty development program on advances in highway technology and traffic system, session 3. So, I welcome and thank Dr. Shiva Kumar to accept our invitation to present his talk on this session. Now, I just want to announce that due to some personal reasons, 2 resource persons were not able to attend their sessions. So in that we have identified 2 right persons. One is Dr. Shiva Kumar. He will be talking on potholes. As you know, potholes is an important part everyone come across through the road. So he will be explaining an overview on the design with respect to laboratory and field performance. Let me brief regarding Dr. Shiva Kumar. Dr. Shiva Kumar is a graduate in civil engineering and postgraduate in highway engineering from Dayananda Sagar College of Engineering, Bangalore. He did his PhD in civil engineering, that is transportation specialization from National Institute of Technology, Karnataka. He has 2 years of postdoctorate experience in University of Pisa, Italy and IIT Bombay with excellent research experience in bituminous mixture characterization. He has worked as research scientist for SIR funded project at NIT Surathkal and research associate for European Commission projects in University of Pisa, Italy, which mainly focuses on using natural fibers, ground tire rubber, waste toner, eggshell powder, etc. in bituminous mixture and road construction. Now, with respect to his research experience, he has got very good publication in Scopus Index Journal, mainly ASCE, construction and building materials, and International Journal of Pavement Engineering with a high impact factor. And he is a reviewer of various journals of material in civil engineering, ASC, International Journal of Pavement Engineering, Taylor and Francis, Road Materials and Pavement Design, Taylor and Francis, Journal of Testing and Evaluation, ASTM, etc. He is a member of 2 professional bodies, ASCE and Institution of Engineers. He has delivered lectures in various engineering colleges. With this brief introduction, I welcome you, sir, for the presentation. Thank you.
Thank you very much for the opportunity, Vivek, sir.
Yes.
Yes.
Sir, you can share your screen and start your presentation.
Is the visibility?
Yes, fine.
Okay, sir.
Okay.
I think I'm audible and my screen is visible.
Yes.
Yeah.
Fine.
Good afternoon, one and all. Myself, Shiva Kumar, and I thank Vivek, sir, for giving me a brief introduction about myself and my education and my experience. And as he told, presently I'm associate professor in Dayananda Sagar College of Engineering, that is in Department of Civil Engineering. Earlier, I did my PhD from NIT Karnataka, and I have 2 years of postdoc from IIT Bombay and University of Pisa. So today I'll be delivering a talk on potholes. That is one of the major issues, and overview, that is the scenario of potholes in India, and if we consider metropolitan cities like Bangalore. And basically, I'm a pavement material man. I'll be talking on the mix design, laboratory performance, and field performance. So the overview of the presentation covers like the pothole scenario in India and Bangalore, and what is pothole, what its background, and how the potholes are formed, and what is the mix design criteria for the pothole patching mixtures, and what are the laboratory studies they have come across on the pothole patching mixtures, what are the repair techniques we have on potholes, and after the repair techniques, once the pothole is filled, what will be the field performance studies we can do, and what is the further scope for research in the pothole patching mixtures. So if we consider like potholes, the scenario of potholes in India, as per the 2014 Times of India paper cutting, we can see that in India and on an average of 7 people die every day due to accidents related to potholes. As we see from the statistics, we can see that the state Karnataka comes second after the UP. And due to potholes, every year there is deaths of around 3,000 and change. And the crashes or casualty, it will be around 15,000. So, and we can see that every year there is a public outrage and newspaper full of pictures showing potholes. That is during the monsoon time. Whenever it rains, the pothole scenario comes into picture in the metropolitan city, that is the urban streets. And the restoration work for these potholes is costing government, any government, like maybe the state government or the central government, lot of money. That costs crores of money. So next, if we come to the pothole scenario in Bangalore, a recent survey has been done by Karnataka State Legal Service Authority, and they have stated that along the 840 kilometer of the urban street, around 3,200 potholes have been there. That is reported by the citizen to the KSLSA. That is through the app. They have developed some app. Based on that app, they have told that around for the 840 kilometers, there is around 3,200 potholes. You can see the statistics here. That is like each zone, east zone, west zone, south zone, etc. Like what is the number of potholes. So based on this data, High Court of Karnataka has direct BBMP, that is Broad Bengaluru Mahanagara Palike, to take action to repair potholes. And they have set the target. In the last November only, they told us to fill the pothole. And this thing has not done. And recently, they have set some deadline, maybe last week or day before, 2 weeks back, Minister Ashok, the Urban Development Minister, has set some target to the BBMP official that by March 30th, everything should be cleared off, all the potholes. So with this scenario, so this is the scenario like in India or in Bangalore. I'm just talking about Bangalore because we stay here, and every year we see like what are the deaths, what's happening there. So based on this thing, I'll put forward like what is this pothole. So this pothole is nothing but a structural failure. Why it happens? It happens due to the water and due to the presence of traffic. So these potholes usually develop on the urban streets after the onset of monsoon, that is during the rainy season. So this problem for the pothole, as it forms, it creates a problem that is in adverse weather condition, where there is a contributed to accelerate pavement deterioration, that is due to water and traffic. So this is a clean picture which will tell you how these potholes are formed. As we see, as the cracks are formed on the surface, the water seeps through these cracks to the road surface, to the base to the soil. So once this water gets freeze, it expands and it forces up the road surface. And along with the water, as there is a accelerated traffic load, so this causes a formation of pothole, as we see here. So the main culprit is the water and the traffic load, and the other is adverse weather condition. One is the freezing and one is dry. So this picture will show you how these potholes are usually formed, and it is a bold shaped structure. So how these potholes are repaired? So these potholes usually BBM official during the rainy season, there will be shutdown of the hot mix plants. You know what is HMA plant? It's a plant where we prepare the asphalt mixture or the bituminous mixture. So as the HMA plant is shut down during the monsoon, that is during the rainy season, they use the antique techniques like placing of soil or bare aggregates on the potholes. So this will not solve the problem. So the remedy for this is a pothole patching mixtures. The mixtures which fill the potholes is known as pothole patching mixtures. So what are these pothole patching mixtures made up of? So these pothole patching mixtures, it is made up of binders and aggregates, and these are used to fill the deteriorated areas in the pavement, which will allow the safe movement of traffic, and it prevents the pavement deterioration, the next level of pavement deterioration. So mainly this pothole patching mixtures, different types are available. One is hot mix and one is cold mix. So in monsoon, we can't go for hot mix. So in monsoon, you should go for cold mix. So what is this cold mix? Cold mix means the mixtures which are prepared without heating the materials. Hot mix means the mixture, that is the binder and aggregates, which are prepared with some mixing and compaction temperature. So along with this hot mix and cold mix, there are several ready-made pothole patching mixtures. So what is this ready-made patching mixtures? It is a commercially available in the market, and which is a combination of binder and aggregates. The binder may be emulsion or cutback. Along with these three, along with the binder and aggregates, they will add some binding agents, additives, that can be polymer, resin, cement, lime, anti-stripping agents. So these are some of the brief pothole ready-made patching mixtures which are available worldwide. So like QPR, UPM, Permapatch, Durapave, Easy Street, and Kandal and Incol. The last one, Kandal and Incol, which in India they usually use. This is a cold mix patching mixtures. So, and these materials will have different gradation, that can be open or dense. And what is the binder? They have their trademark binders like QPR liquid oil blend or UPM liquid oil, or in Permapatch some polymers will be used with the cutback. In Durapave also they use polymer. In EZ Street also they use polymer. Whereas in Kandal or Incol mix, which is approved by IRC, they use emulsion with dense gradation, and the binder content they used for this is 4.5%, and the production temperature we can see it is very less. So this is a brief overview on the ready-made pothole patching mixtures or the cold patching mixture which are available. Hot mix is the normal mix which we prepare in the HMA plant. So above this, after this, we will see what is the mix design criteria, how this pothole patching mixtures can be designed. So to know that, we have to see some of the critical issues. So what are the critical issues in the mix design of the pothole patching mixtures? One is aggregates gradation. Next one is the binder type, and which type of binding agents use, and what is the curing regimes. As this is a cold mix or a ready-made, it requires some curing regimes. So first we will consider aggregate gradation. So aggregate gradation, as I told you here, it can be open or dense. If it is a dense, it perform well. It is a open, it has some, so that I will tell you in the next summary. So in aggregate gradation, we can go for open or dense gradation. In binder type, we can go for cutback or emulsion. Cutback, rapid setting, slow setting, that MC, that in cutback, MC, that is medium curing, slow curing. In emulsion, rapid setting, medium setting. There are a lot of things, MC 800, MC 600, like that. And we have to see that it should have a lower viscosity. Next, if you consider the binding agents, a lot of binding agents can be used like cement, fly ash, GGBS, hydrated limes, fibers can be used, along with the nanomaterials like nanoclays or epoxy resins can be used. So if we use these binding agents, we can improve the durability properties. So that is the main criteria. And in the potholes, the next aspect is the curing regimes. So once we prepare the mix, we have to cure it, because it is a cold mix, so it should be cured. So as we know, based on the review or based on the mixes, a conditioning temperature of 40 to 60 degrees Celsius for a 3 days period can be done. So this curing regime simulates 1 to 6 months of conditioning in the field. After the curing regimes, in addition, we have to involve, it also involves evaluation of some volumetric properties, optimum moisture content at it is a cold mix, and asphalt content and coating, that is the moisture in the damage, that should be minimum threshold of 90% coating. So this is the summary on mix design parameter. So if we consider gradation, so then that it comes workability and durability. So if it is an open gradation, workability will be good, but durability will be poor. If we consider dense gradation, workability will be poor, whereas durability will be good. Next comes the aggregate shape, angular or round. There, if it is angular, workability will be poor, durability good. Like that, if you come to binder viscosity, low viscosity should be used. If it use, we have a good storage stability. That is important, no curing, and it will have good workability. But for in order to improve the durability, we can go for anti-stripping agent. But if we go for higher viscosity, durability will be good, but workability and storageability will be not be there. Next, anti-stripping. So in cold mix patching mixture, anti-stripping should be used. That is, it is good. So that is the summary of the mix design parameter. So next comes the laboratory performance. So there are various laboratory tests they have done on the pothole patching mixtures. So some of them include stability, adhesion, cohesion, workability, and durability. So rutting and the moisture is the main thing we have to focus on the pothole patching mixtures. So I think you know what is rutting. Rutting is the wheel depression along the path that happens due to the wheel load. Moisture happens due to the water. So as I told in the starting slides, as water and traffic is the main culprit, so we have to look into the durability properties, that is rutting and moisture induced damage. So what is this stability test? As we know, stability, Marshall is there, immersion compression is there. So this lot of researchers has worked on this. Then comes adhesion. Adhesion is nothing but the how best the bitumen will coat the aggregate. So that is called adhesion. So the binder which we use should have a good adhesion to the aggregate. In order to assess that, we can go for coating and stripping test. Coating may be boiling test, stripping test, Nicholas stripping test. We can there are a lot of tests. In addition, nowadays they are also using some of the techniques like image processing techniques in order to assess the coating percentage. As I told here, 90% of coating, the threshold coating percentage. So image processing is one of the new technique which we can work out in order to assess the adhesion. Stability, normal Marshall and immersion compression test or ITS test, that is indirect tensile strength, also we can go for. Next comes the workability. So in workability, we can go for blade resistance or slump based test. That is the normal test what Department of Transportation in Texas or Virginia they have developed. Nowadays, workability can also be assessed using densification indices, that is based on superwave mix design or the superwave gyratory compactor. We can assess the workability using compaction densification index and traffic densification index. That is the compaction densification index is a direct measure of workability, where if the compaction densification value is lower, it is more workable. If the compaction densification index is more, it is less workable. So that is also one of the parameter we can look into in order to assess the workability. Next comes the cohesion. For cohesion, they have given a simple test, that is rolling sieve test. That is also given in Indian code, that is IRC. And the last one, that is which we have to focus on, is the durability. That is rutting, we can go for wheel tracking device. That is number of passes, how many, what is the rut depth for the number of passes. And next one is the ITS test in order to assess the moisture induced damage. That is indirect tensile strength. That is based on the TSR, tensile strength ratio. This is the coating percent I told, 90%. Like that in ITS also, we can go for TSR, that is tensile strength ratio. That is nothing but the ratio of ITS sample, dry condition and wet condition. Okay, dry condition means we will not condition it directly, we will prepare the sample and we will assess the ITS value. Wet condition means we will go for alternate freeze and thaw cycle. That is we will keep in the freezer for 18 hours and that is minus 16 degrees Celsius, and in the water bath at 60 degrees Celsius for 24 hours, then we will assess it. That is the indirect tensile strength. Based on the ITS test, we will calculate the TSR and we will assess the moisture induced damage, and that TSR value should be more than 85%. So these are some of the laboratory tests which the researchers and road agencies have been evaluated on pothole patching mixtures. So this is a brief summary on the laboratory test, which I have made a table form, so that how this laboratory tests are affected by the mixed design parameter. The mixed design parameters will directly affect the laboratory performance. So if we go for, let us take an example of gradation. So if it is a dense gradation, what happens to the stability? So we can see from the table, if it is a dense graded mix, the stability or adhesion, workability, rutting, it increases. So if we consider in the second line, the OG means open graded, we can see that there is a decrement in the stability, workability, rutting, moisture, etc. So next we will consider the binder type. Okay. In binder type, cutback or emulsion, if we add the binding agents, then there will be increment. If we don't have the binding agent, there will be decrease in the laboratory, decrement in the laboratory performance. Like that only the curing regimes. What is this? LH is nothing but longer curing at high temperature. SL means shorter curing at low temperature. So we can go for longer curing at high temperature. As we see, for longer curing at high temperature, all the properties like stability, adhesion, workability, rutting, and moisture has been increased. So this is just a summary of the laboratory tests which I have gathered. So next, once the mix design is done and the mix is done, then how we will repair the potholes with this mixes, maybe cold mixes or the ready-made pothole patching mixes. So there are a lot of techniques like throw and roll, throw and go, semi-permanent pothole repair method, spray injection hole repair method, edge shield method, and the last one is full depth roadway hole replacement. So first we will see what is this throw and roll method. This figure, this figure will tell you about the throw and roll method. In this method, what they will do is first the material will be placed in the potholes. And before placing the pothole, they should see that there will be no water or debris. Then the material will be compacted using the roller or the track tires to allow for the tighter patch. And the maintenance crew will move to the next potholes, and the same procedure continues. So here, the potholes will be cleaned, and then the material, which material we have, maybe the ready-made or the cold mix, will be placed, and then it will be rolled. So that's the name throw and roll method. Next one is throw and go method. In this, it is one of the common method they usually do in BBMP officials also. They will do this type of things. Here what they will do, they will take the material, they will quickly apply it, and they will go off. They will not roll it, they'll just throw it. They will just use the hand compactor, they will compact it. Here we can see the one with the shovel here. They will just put it, they just compact with the hand thing, and they will go off. Here in using in throw and go method, the material will be shoveled into an unprepared pothole, which will contain water or debris. We have to see that the water and debris will be not be there. And once with the shovel, they will compact it, and the next compaction will be left to the traffic. So that is the throw and go method. Next is semi-permanent pothole repair method. In this method, what will they do mean, first the pothole patch sides are squared up. First they will square it. This figure, you can see this, they will square it up. Then until vertical side exists, Then the patch is, then the material will be put, they will make a square patch. If the patch is irregular, they will make it as a square patch. And after that, they will put the material, they will compact it. And a semi-permanent method, the most commonly equipment they use is material trucks, compaction device, that is vibratory roller or a single drum roller, or by the jackhammer or cold mining machine. So next, after the semi-permanent pothole repair method, then comes spray injection repair method. Here what they will do, this figure, spray injection, you can see from the figure. Here what they will do, first the potholes, they will the potholes which are formed, they will fill clear with they will clear if the water or debris is there. Then they will apply some tack coat as a binder. It will be sprayed into the potholes on the sides and the bottoms. Then the materials, that the asphalt and the aggregates, will be blown into the pothole, and the patch area will be covered by the aggregate layer. Once it is done, they will once again they will put the tack coat on that, and they will leave the traffic, they will open the traffic for the method. So in the spray injection technique, the device will have virgin aggregates and heat emulsion. If you see here, you can see that the truck will contains both the binder and the aggregate material. So next comes the edge seal. So in edge seal procedure, what they will do is the material will be placed into the pothole without any prior preparation or removal of water or debris. The material will be compacted using truck tires or the vibratory roller. Then the compacted patch, the potholes which will be compacted, will be checked for the levelness. If we see that there is any depression or something like that, then it will be rolled again. And this after the edge seal is done, the patch will be left for drying for 1 day. So they will not allow the traffic open of the traffic. So once after the patch is done, the layer of cover aggregate will be placed with the tack material to prevent the tracking. So next, after the edge seal repair, then comes the full depth roadway hole replacement. Here the full depth means the whole thing will be removed and the hole will be replaced. So this is some of the repair methods. So once repair is done, next we have to see that how, once the patch is fixed, the pothole patch is fixed, we have to evaluate it. That can be done using field performance. Before going into the field performance, we have to see that the pothole patches will come across some of the distresses. So what are these distresses in pothole patches? That is bleeding, dishing, pushing, edge disintegration, mispatching, raveling, and alligator cracking. So these are some of the common distresses which happens in the pothole patches. So what is this bleeding? Bleeding is nothing but flushing of asphalt. If excess binder is there, the binder will come off on the surface of the patch. So why this happens? This happens due to the insufficient voids and excessive binder. So next is dishing. Dishing is nothing but a bowl shaped deformation. Why it happens? It is happened due to there is a instability of the mixture. The mix which we have done, the stability is low, then this happens. And if we have not given enough compaction, so that is inadequate compaction. Next is pushing or showing. So it is nothing but a vertical or horizontal movement in the patch. And why it happens? It happens due to lower adhesive property and instability of the mixtures. So next is the edge disintegration that happens at the edges. So why it happens? When the patch material loses its adhesion at the sides. Whenever we put the potholes, patching mixture in the pothole, we have to see that the edges are also properly compacted. If the edges or the sides of the potholes are not compacted, there will be loss of the material due to the adhesion properties. Next is the missing patch. So this is nothing but the loss of patching material that is caused due to the poor adhesion, cohesion, insufficient compaction, and some alligator cracking. That is the cracking of the potholes. Next is raveling. Raveling is nothing but the loss of aggregate from the surface of the patch. And why this raveling occurs? It occurs due to stripping, poor cohesion, lot of fine aggregates, and poor aggregate interlocking property. Next comes the alligator cracking. And cracking usually occurs due to the freeze and thaw cycle, that is alternate adverse weather condition or the alternate weathering, that is freeze and thaw. It usually happens in the during the winter season, that is in the monsoon or in the winter season. So this is about the common distresses. So once the repair has done and we know of the common distresses, then the field performance can be done. So there are a lot of research available from they have done, like researchers, Department of Transportations, Highway Maintenance Organization. They have evaluated the performance and how the effectiveness of the pothole patching mixture is there, and which technique, that is which pothole repair technique is good and all. So I'll just go through it. So in 1986, Thomas and Anderson has investigated the longevity and the cost effectiveness of different pothole repair methods. That is throw and go, throw and roll, semi permanent, and spray injection in USA. According to the field of observation, they have said that some innovative or more expensive materials can provide longevity and it will be cost effective. So innovative or more expensive materials, maybe the binding agents or the innovative materials we can use. And the spray injection method or the semi-permanent procedure is one of the good pothole repair methods they have done. In then SHRP and LTPP, that is SHRP Strategic Highway Research Program, and a long-term payment performance program, which is in USA. These are some of the programs like what we have in India, that is NHA or NHDP or IRC. They have some programs. So that programs, they have funded the agencies, and they have studied some of the things where they have focused on which pothole repair method is suitable and which is effective. So based on that, they have found that the roll and throw and roll technique is effective, and the semi-permanent procedure is more cost effective, because the semi-permanent procedure requires lower labor and equipment costs. So next, Texas DOT has developed an accelerated payment test in the field to evaluate the rutting potential, that is the rutting potential, that is a wheel load of the pothole patches. They have said that they have installed some of the machineries like mobile load simulator. They have applied accelerated wheel loading test, and they have evaluated the rutting properties. And recently they have in Texas DOT, with the help of some researcher like Dong et al., they have done a 6-month field survey performance, and they have concluded that mixing patch and edge disintegration is one of the common distresses, and this happens due to freeze and thaw cycles and debonding. And these are most commonly encountered distresses in throw and roll patches. And Virginia DOT also has evaluated some of the performance rating in order to assess the field performance. So here the ratings are ranged from 1 to 4 using some formula that can be given as performing rating is equal to 0.05 into bleeding plus 0.07 into dishing. This is the formula based on the payment distresses, and the performance rating will be in the form of 1 to 4. If it is 4, it indicates the best condition, and if it is 1, it indicates the poorest distress condition. So this is some of the field performance studies, laboratory performance, and repair techniques which I wanted to share with you. And based on all this, we have I can summarize there is a lot of scope for the further research. the first aspect is the design criteria. So here we can it will be just I'm giving this slide because I think there will be a lot of MTech students or the researchers who will be wishing to do something on pavement materials or bituminous materials. For them it will be useful, so I thought of I'll just summarize the thing and I can tell you what will be the scope of research on the pothole uh, patching mixtures. So the first aspect is the design. As I told, it is one of the critical issue, like which gradation we have to take, what is the binder, what should be its viscosity, what is the binding agents we have to use, and what is the curing regime. So here we can focus on, we can do some design of experiment for the different, like aggregate gradation if it is dense, or aggregate gradation, dense gradation or open gradation, binder, cutback, emulsion, curing regimes, binding agents you can take 3, and you can design a design of experiment through DOE. You can design experiment and you can do the test. After that you can optimize through response surface methodology or ANN models, and you can come out of a beautiful topic that is on the design aspect of pothole patching mixers. That is designing the experiment. Based on the design of experiment, you can optimize using the response surface methodology aspect. So that will be one beautiful topic. Maybe MTech students someone can do. Next, even IRC, Indian Road Congress, has suggested one design and guidelines for pothole patching mixture, that is SP116. And the IRC suggests some basic tests like wet coating, static immersion, water resistance, and workability. But it has not focused on durability properties. Maybe that is related to moisture damage and rutting. Fatigue, like it's not necessary, but we should focus on moisture and rutting. Moisture is nothing due to the water, and rutting due to the wheel load. So someone can assess the different pothole patching mixtures, that is maybe the Kandal mix or ready-made mix. There are a lot of ready-made mix available in the market, like Hinkol or Durapave, Permapatch, Road Bond, the Kandal mix, that you can take some 5-6 materials along with the tests which are suggested by the IRC. You can also work it out on moisture damage, that is through ITS, and rutting, that is wheel tracking test. So next, once we do all this, the summary also tells that this pothole patching mixtures, the laboratory and field performance is inconsistent. So someone can focus on the literature review suggests that if some pothole patching mixtures, it performs good in the lab, but it performs poor in the field. Some mixes perform poor in the laboratory, but it performs good in the field. So someone can develop a mix or take some of the mixes which are available, ready-made or the Kandal mix. They can take some 5-6 mixes. They can perform field evaluation, and they can perform laboratory, and they can simulate both of them. Next is use of some industrial waste and RAP, that is recycled aggregate pavement. So there are a lot of recycled aggregate pavements, and it already contains some of the binders. So we can work out the RAP in the pothole patching mixers. And industrial waste like steel slags, that is one of it has some pores, and Kandal sir only has done some research on steel slag, and they are told that it can be used as a fine aggregate. Usually this pothole patching mixture gradation starts from 4.75, that is fine aggregates only. The gradation comes from 4.75, 2.36, like that. It goes till 75 micron. So Kandal sir has told like steel slag can be used as a replacement for fine aggregate. So you can work on industrial waste like steel slag and RAP. You can develop your own mix by substituting the virgin aggregates. Virgin aggregates, nothing but the granite or the basalt, which is available, locally available in your area. And you can compare the things. Pothole patching with the conventional aggregates, and pothole patching with the steel slag, or pothole patching with the RAP, and you can work it out. Like that, you can go work on some of the binders we can modify it with polymers or crumb rubbers with the cutback and emulsion, and you can also work it out. Next is the use of chemical additives and anti-stripping agents. Like there are a lot of anti-stripping agents. Anti-stripping agents are the agents which will lower the moisture damage, and there are some of the chemical additives which will improve the rutting properties. So you identify some of the additives and agents, and you try to mix it with the normal conventional aggregates, and you can assess the property. And the last one is last one I can tell you is, in USA they have used some road patch they have developed. So this is road patch is nothing but they will fill the pothole. After that they will cover it with some patch. That patch is made up of fiber reinforced glass sheets. So that also we can develop some of the road patch in India, and we can assess it. So this is briefly about my talk, and I thank everyone for giving me the opportunity. Uh, Thank you. So if you have any queries, you can just ask me. Like I'm ready to answer it. Yeah. VK Galot sir has asked a question about on use of wrap or construction waste for pothole. Sir, as I told you in the last slide, that is one of the interesting thing we can use as this 1 minute. Yeah. As I have told you about the industrial waste or wrap, so that is one of the interesting topic. Like wrap, already a lot of research are done on cold mix wrap material that is called cold recycled mixtures. So that we can use, and they have successfully implemented it also. So this wrap, that it can be used successfully in the patching mixture, as it already contains some amount of binder. We can use some of the rejuvenators along with the wrap, so that we can make a proper mix. If we come into industrial waste, as I told you, like steel slag, like Kandal sir has done a lot of research on that, and they are told that steel slag may be LD, BOF, or EAF slag. The fine aggregates of this maybe below 4.75, we can successfully use in the pavement construction. So we can use the steel slag or wrap in that. If that's what I can tell, sir. So any more thing I can tell me, so you can just put a chat on that. You can just put a message on the chat. I will help you out. So next, this is about the field and laboratory performance. As I was looking into some of the literature, we can use some artificial intelligence or machine learning models to assess this one. Maybe identification of the potholes in a Bangalore area. Like you can take north zone, south zone, east zone, like that. We can use the RSGIS thing. We can take the pictures of the potholes and we can simulate with the ANN models or the CNN models, and we can give. It can be a very good topic. Even I was planning to some students in our college also, like assessing or the uh, uh, how many potholes are there, what is the effect of the pothole, how it will do using the ANN, that is using the artificial intelligence. So that will be one of the good topic we can look into it. Or the payment evaluation, we can briefly tell it. Vivek sir? So I think some master students are there. They can just they can throw some questions, or if they have any doubts in all of this, we can just so if you have any queries or related to this, you can mail me. This is my mail ID. And I thank,
Yeah. You can speak, sir. You can speak, sir.
Yes, sir. Nothing. I just wanted to. Sir, namaste, sir.
Sir, namaskara.
Sir, chanagideera.
Sir, we have one more question for you.
Yes, sir.
Throw some light on use of wrap or construction waste.
Yes, sir. I spoke about it to Galot sir has done. Yes, okay. I just spoke about it.
Okay.
Yes, sir.
Okay. Okay, sir. I think I should thank you on behalf of all the participants
yes,
here.
Yes,
and we hope to see you soon, sir.
Yes, sir. Thank you very much, sir. I'm proud that I'm your student. Yes. I hope you remember me, sir.
Yeah.
I did engineering in Dayananda, Sagar. So you were my teacher. You taught me traffic engineering.
2011, I think.
11. Yes,
correct?
sir.
Correct.
Yes, sir. 11
Nice to see you on this platform.
Yes.
Actually, very proud to see you on this platform.
Sir, I'm proud that I'm in front of you, sir, speaking.
No. Thank you so much for being with us. Matte, we will
Yes.
be calling you frequently.
Yes, sir.
For your expertise and
yes, sir.
be with us.
Thank you. Thank you very much, sir.
Thank you so much. On behalf of all the participants, I would like to thank you once again.
Yes, sir. Thank you very much for your precious time. Thank you.
Yes. Thank you so much. Thank you so much. So this is to all the parties. Yes, you can leave. You can leave.
Okay.
This is to all the participants. Tomorrow we have the session at 10 o'clock. Till then, keep yourself safe. Okay, there'll be a link which will be sent to you for the feedback link. Yeah, feedback. Yes, please do get us the feedback. Yeah. Thank you, one and all.